Let ABC be three distinct positive real numbers such that 2a to the power log a base e is equal to bc to the power log b base e, and b to the power log 2 base e is equal to a to the power log c base e. What is the value of 6a plus 5bc? First of all, I would like to write it as 2a to the power natural log of a is equal to bc to the power natural log of b. So log of any number x with base e can be written as ln of x. So for this I write ln a natural log of a, and for this I write natural log of b. To reduce this equation, we take log on both sides. Log of 2a to the power log of a is equal to log of bc to the power log of b. Now log of x to the power m with any base a is equal to m log of x. Using this equation becomes log of a into log of 2a is equal to log of b into log of bc. Now another property of log is log m into n is equal to log m plus log n. Using this property, log a as it is. Now log 2a I can write as log 2 plus log of a is equal to log b as it is, and log bc becomes log b plus log c. Now assume let log a is equal to x, log b equal to y, and log c equal to z, and similarly log 2 equal to k. Because a, b, c are distinct numbers, so their logs will also be distinct, and log 2 is a constant, so I'll write it as k. So this equation becomes, instead of log a I'll write x, instead of log 2 it is k, plus log a becomes x equal to log b is y into log b is again y plus log c is equal to z. So this is equation number 1. And the another equation that was given to us is this. So writing it as b to the power log 2 is equal to a to the power log of c. Taking log on both sides, log b to the power log 2 equal to log a to the power log of c. Now using the property of log x to the power m is equal to m log x, we get log 2 into log b is equal to log c into log of a, which ultimately becomes k into y is equal to z into x. Let it be equation number 2. Now from second equation I can write k becomes zx upon y. Now using this value in equation number 1, equation 1 becomes x into zx upon y plus of x equal to y times y plus z. Taking x common from this bracket, we get x into x inside the bracket, z into y plus of 1 equal to y into y plus z. Now taking LCM also, so we get x square into z plus y equal to y square into y plus z. I can write it as x square y plus z, taking this term to the left hand side. So minus of y square into y plus z equal to 0. Taking y plus z common, so we get y plus z into x square minus y square equal to 0. Now y plus z as it is. X square minus y square is x minus y into x plus y, which is equal to 0. From here I can write either y plus z equal to 0 or x minus y equal to 0 or x plus y equal to 0. From here y is equal to minus z, from here x equal to y, and from here x equal to minus y. Now clearly this case cannot be considered, so we reject this case because initially it is given that the numbers are distinct. So both the numbers cannot be equal. So we have only two conditions, that is y is equal to minus z or x equal to minus y. So this becomes y plus z equal to 0 and x plus y equal to 0 from here. Now replacing with their original values, this becomes log b plus log c equal to 0. Applying the property of log, we get log b into c equal to 0. And log 1 is 0, so bc becomes 1. And here x becomes log a, y becomes log b equal to 0. B becomes log of ab after applying the property, which is again 0, and log 1 is 0. So clearly from here ab is equal to 1. Now using the value of bc in this given equation, we get 2a to the power log a is equal to 1 to the power log b, which is again 2a to the power log a equal to 1. Now if we pay attention, I can clearly see for a equal to 1, equation becomes 2 into 1 to the power log 1, and log 1 is equal to 0, so 2 to the power 0 is equal to 1. So that means this is a valid value of a. Also, if we make the base equal to 1, that is only possible when a equal to 1 by 2, because for 1 by 2 it becomes 2 into 1 by 2 to the power log of 1 by 2, which is equal to 1 to the power log of 1 by 2, which is again 1. So a equal to half is also the valid value. So clearly from here I can say a is equal to 1 and half only. Now check the values of a for the second equation. So when a is equal to 1, we get b to the power log 2 is equal to 1 to the power log c. So b to the power log 2 becomes 1, and ultimately from here b is also equal to 1, which is not possible because a, b, c are distinct numbers and here a and b are equal. So from here I can say a cannot be equal to 1. So only value of a which is possible is equal to 1 by 2, and from earlier we found out that bc is equal to 1. So 6a plus 5bc becomes 6 times half plus 5 times of 1, which is equal to 3 plus 5, which becomes 8.